Hello, people of geometry. Welcome to 8-4. I hope that everything went well with the quiz. There's only about one or two parts left of this, and then you're on to Unit 9. So we've been talking a lot about area, so now we're going to take it one step further. And what happens when we have irregular polygons or composite figures? Okay, so what happens when we have those things that don't work out so nicely? That are a little bit trickier to kind of figure out the areas of. So now let's take a look. So now if you take a look of a map of the United States, very, very few states work out well as far as being a rectangle. Okay, so Colorado is a good rectangle. Wyoming's a pretty good rectangle. You could argue that Nevada or North Dakota is almost a rectangle. But hardly any of the other ones are even close to it. I mean, maybe Pennsylvania a little bit, but that's it. It's very hard to figure out areas here of these oblong, these weird shapes. So what do we do? So here's how I do it. So I put a graph over top of it, okay? I put a number of squares over it. I count the number of full squares. I count the number of partial squares and divide by 2. Then I add the numbers from part 1 and part 2 together, and I multiply by the area of one square. So, fulls, partials divide by 2, add together, multiply. Okay, let's put this into practice here. So, if we look, we have a lake below. And each square is 2 miles in length, okay? So that's 2 miles this way, 2 miles this way. So the area of one square would be 2 by 2, so 2 times 2, which is going to be 4 square miles. Okay, so first thing, count the full squares. So full squares, I would say, start right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I'm going to say that one gets cut off. So 20, 21, 22, 23, 24, 25, 26. So I'm going to say I've got 26 full squares. And now for partials, you count everything that has part of the lake involved. So I would start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You could almost argue this one for 12, 13, 14, 15, 16, 17, 18. You could almost call that 19, 20, 21, 22, 23, 24, 25, 26, 27. So that's 27 partials divided by 2 is going to be 13 and a half. So I add them together, 26 plus 13.5. So that'll be 39.5 times 4, because that's how big each square is. 39 and a half times 4 is going to be 158. So my estimate as to how big this lake is 158 square miles. And that's all I'm doing. That's it. I don't have to overthink this. So now here, each square below is a quarter mile in length. So that's 0.25 times 0.25. So 0.25 times 0.25 is going to be 0.0625. So that's in terms of miles for each square. So again, count the holes, and you could almost make an argument that there's very few whole squares here. Maybe you could argue this one. Maybe you could argue this one. Maybe 3. I would say 4, and that might be about it. So I'd say 4 whole ones. Then you've got a whole bunch of halves. I'm going partials. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I don't know if you can argue that one. 15, 16, 17. You could almost argue that one. 18, 19. And I'm going to say, I'm not sure, I'll throw that one in there, 20, just because it dips in a little bit. So I'll take 20 divided by 2, and that's 10. So then my total is going to be 4 plus 10, so 14, times that 0.0625. So that's 0.875. So how big is this lake? That I am. Miles squared. So not quite a full square mile. Okay, but that's all I'm doing. But you have to be picky. Now, there is absolutely some leeway here. There's absolutely. You might count one that somebody else might not count. That's okay. There is some leeway. This is, you're looking for an approximation here. Okay? It's not, you're not going to get down there and measure every little curve. You're looking for an approximation, and that's okay. That's what we're going for. So now a composite figure is something like this. A composite figure is a combination of things we've talked about before. So, you have a triangle, you have most of a circle, you have most of a circle over here, you've got a square, you've got what is probably an isosceles triangle, something like that. But now you have to figure out what's the area of this whole thing. So that's kind of what we're looking at for composite figures. So you're separating it into regions that are your basic geometric shapes. So you're breaking this down into shapes that you can put together. So if you look here, I'm going to break this apart by semicircle. Let me do it this way. By triangle. And by rectangle. Here. Okay? So I've got semicircle, triangle, and rectangle. So semicircle, well, the area of a whole circle is pi r squared. But I only want semicircle, so I'm just going to divide that by 2. So I want pi times 4 squared divided by 2. So that is, when I do all that, that's 25.13. So then for a triangle, let's see, that's going to be 4. That's going to be 4 as well. So you're going to go base times height divided by 2. So that's just going to be 4 times 4 divided by 2. So that'll just be 8. Okay? Actually, well, maybe we're not sure. That could be wrong. Maybe we're not sure what that height is. Okay, maybe we have a situation where we have a right triangle. We know that is 5.7. We know that is 4. We don't know what that is. In fact, I don't think we do. So we're going to consider, we might have to do some Pythagorean theorem. Okay, remember that old thing. That thing never goes away. So h squared, I think that we're going to have to do that. I don't think that's 4. I think I might have misspoke. So h squared equals 5.7 squared minus 4 squared. So h squared equals 16.5. So when I square root that, I get 4.06. So very, very close. Very, very close. I mean, if you called it 4 times 4, I probably wouldn't count it wrong. So base times height divided by 2, you end up with 8.12. So there's my area there. The rectangle is pretty easy. A rectangle, just 4 times 7, 28, and move on. So now I got to add all those things. So my total area becomes 61.252 square feet. Label is important here. So make sure you label, please. But that's what I'm doing. I'm taking piece by piece. I took half of the semicircle. I took half of a circle, so I just divided it by 2. I'm breaking it apart and trying to take it piece by piece. So now here I've got a semicircle, but I've also got a trapezoid. Okay, so here's what I've got to consider. I'm going to consider that this length here, this is my 22. Okay, so if this is 22, that makes this length 9. I've got to figure out that. I've got to figure out that. How do I know this is 9? Well, I know that this part is 22. I know that the whole thing is 9 or 31. So I got to take 31 minus 22 and get 9. So here I want to do Pythagorean theorem again. 15, 9, figure out that. So 8 squared and 9 squared equals 15 squared. So h squared is 144. So h is just going to be 12. You know, square root, square root. That's all I'm looking at. So this becomes 12. Why is that important? This here also matches up to this down here. So for my semicircle, for my half circle, my radius is actually 6. So for my pi r squared, and since it's a semicircle, I want to divide by 2. I want 6 squared times pi divided by 2. All right, a little calculator mashing, and I get 56.55. Why is this handy? Well, for the trapezoid, my height is 12, and for those of you that forgot what trapezoid is, okay, that's the first base, top, and bottom divided by 2 times my height. So that'll be 22 plus 31 divided by 2 times 12. So I'll go 22 plus 31, and I get 318 centimeters squared. This one's also centimeters squared. So I add the 56.55, so 374.55 centimeters squared. That's my answer. That's my answer. So it's nothing more than putting together the pieces that we've done before. Okay, so now this one, I would do this one actually a little bit different than other people would. You can absolutely like drop down a line here. You know, this is still 12. You know, the whole thing is 15. That makes this length 7. Okay, you can absolutely do the area of the rectangle plus the area of the trapezoid. That would absolutely be fine. So this would be 12 times 8. So that's going to be 96. This would be 12 plus 5 divided by 2 times 7. Eight and a half times 7. So it's going to be 59.5. So when I add that, I get 155 and a half. That's perfectly fine. Some people might go across this way, okay, and do it that way and go this way with the trapezoid, this way with the square. All of those are fine. One thing I might do is try to kind of go backwards a little bit to go forwards. And what I mean when I say that is, if I complete this rectangle, okay, then the area of the whole rectangle would just be 12 times 15. Okay, 12 times 15. So if this was a whole rectangle, like including this part, my area would be 180 inches squared. Okay, now what I would like to do though is I want to figure out the area of the rectangle, or not the rectangle, sorry, the triangle, which isn't tough to do because 12 minus 5 is going to be 7 right here. And 15 minus 8 is going to be 7 right here. I don't know why I put that square there. So my triangle is just going to be 7 times 7 divided by 2. So that's going to be 24 and a half. So 180 minus that is going to give me 155 and a half inches squared. Okay, so a couple different ways you can do it, and every way will get you the same answer if you do it right. So that's what you have to be careful with. Okay, a couple different ways you can do it. Okay, last one. Let's take a look. This is figure out the area of the shaded region below. So what we need to do is take the area of the big rectangle minus the area of the little rectangle to figure out the shaded area. Okay, so we need to figure out how big the long piece is. Well, if my middle piece right here is 100, and it's 25 on each side, so that makes that 150 feet. And then if this length right here is 20, if this length right here is 20, and then it's 25 on either side, so that's going to be 70 feet. So the area of the big one is just going to be 150 times 70. The area of the small one is just going to be 100 times 20. So that's going to be 10,500 minus 2,000. So my answer is going to be 8,500 square feet. But remember, all they want is the shaded region. So I take area of the big minus this area in here that's not shaded, and that gives me my answer. That's it. That's it. Okay, play around with some of these ideas, see what you can do, see what might be a clever way to kind of break them apart, and then get ready for your last section, which is 8.4 part 2. Thank you.